Hello, my name is Evan Toller, and my talk today is Design Principles for ELT Database Destinations. I'm an engineering manager at Airbyte, and I manage our destinations team and our connector operations team. And if you like my talk, I'm Evan Toller on all the socials. The main crux of this talk is that making a good sync destination for ELT or ETL is both a user experience problem as well as a technical problem. Of course, you want your syncs to be fast, reliable, all those things. But at the end of the day, you're making a table that somebody else is going to use or another system is going to consume. And this talk is a blend of the foundational work we've done at Airbyte so far and the features we're building soon, and how we think about building these best tables from a user experience point of view. So this past year, we had a project we called Destinations V2, highly technical name for the next version of our destinations. And in a nutshell, we wanted to make our database and data warehouse destinations better. And better is a fuzzy word. And so we focus kind of on these four topics. First, we use DBT, that's the transformation tool, DBT from DBT Labs, to create what we called our final tables in our data warehouse destinations. But it was really buggy. It was another process that we had to spin up. It wasn't very resilient to type errors and changes of data types. And it was kind of slow. Schema changes also required a full resync. So if a column that used to be a number became a string or vice versa, we often couldn't handle it. Number three, you didn't get any data until the end of the sync. So especially for big first-time syncs, if that was going to take a long time, there was no way to look at the data until the way end of your sync to see what it was going to look like, what columns you were going to end up with. That was a long thing to wait for if you wanted to make adjustments. And then finally, finding the data you wanted in your data warehouse was slow. We made a lot of subtables. We made SCD tables, and finding the data you wanted was slow in your data warehouse destination. We made too many tables, and they were hard to find, they were slow to create, and they were expensive to create. So what did we do? We reached out to our community with our plan. You can see here, we had a GitHub issue. We also had a Slack issue describing what we were going to do. And the community was really excited about it. They were feeling these pain points and liked our change. So through talking to our community members, we came up with 5 main principles for our ELT syncs. And these are: 1, make the tables easy to use. Of course, the primary goal. And we'll get into what that means in a little detail. Second, we wanted to decouple sync errors from data errors. Sync errors mean we had trouble moving the data, and data errors means that something went wrong in the final destination. Maybe the data was too big or the wrong type. We want to maximize observability. We want to make schema migration simple and fast. And again, we wanted to make data appear in its final form as quickly as possible so folks could use it. So let's talk about how Airbyte moves data. We have a schema that we get from the source. So in this example, it's a users table, ID, first name, age, and then address as a sub-object. And we serialize data into JSON and move it through Airbyte. In this example, you can see user 1, Evan, is pretty reasonable. And user 2, Brian, here, has a weird value for age. And this will be important later because often we have sources that emit improperly typed data. So here's where we ended up with. This is the table you'll get today in Airbyte destinations that use V2. And on the right-hand side, you'll see the tables you expect: ID, first name, age, and address remains JSON. And we can present strongly typed columns in the ways that users expect. And on the left side, we have additional metadata we add to your sync. Every row gets an ID. We give you the extracted at timestamp. So if you have data like I do here that doesn't have its own timestamp information, you can still know about when it was moved and when it was synced over. And this new Airbyte meta column. We're going to eventually add sync ID so you can tie it back to the Airbyte platform and know which sync moved this data. And we have an errors column. So we can finally tell you that, hey, for user 2, age, which was fish, is not a valid integer. So in the strongly typed age column, there's nothing there. But you can go back to the errors column and see if something was wrong. But we still give you as much of your data as possible that is valid. Compare that to what we used to do. In the V1 world, the before times, we would make 2 tables. We would normalize out users into its 2 columns, users and addresses, and link them back together, which meant there was a join, which meant it was hard to find stuff. And you'll notice user 2 never got here. That would have been a problem. We'd try to cast the word fish into an integer column age and things would blow up. So the problems with this old schema where we had too many tables, data errors weren't handled, and you had no or little sync observability. So let's get into this. Provide easy to query tables. That's goal number one. So the three principles here are we want wide, denormalized tables that don't require joins. In data warehouses, wide tables are great. All the information you want is there, and you don't have anywhere else to look. It's pretty straightforward. And we also don't want any more subtables. So this means that we have to keep sub-objects as JSON. Now, in modern data warehouses and database destinations, they can all handle JSON types, super columns, variant columns, depending on your database. They all exist now. And it's really easy to query JSON data. This wasn't true in the past. It is now. So let's use it. We also don't want to explode this JSON data because we're not really sure what all of our users want. Some people find all the properties in that JSON very valuable. Some people don't. And that's what your transformation step is for, the next step in your ELT process. Extract it if you need it. It's possible, but we're not going to waste time and money doing it by default. It's up to you. Next, we decouple sync errors from data errors. So as I said earlier, sync errors are problems about moving the data. These are errors you see in Airbyte, like sync has failed, we're retrying. As we move data, there's all sorts of reasons that things can go wrong. Maybe there's networking errors. Maybe we run out of memory. Maybe the source went down, is unreachable. It could be a credentials error. These are the general class of errors that Airbyte is really good at dealing with. We have retries. We have webhooks to tell you when something goes wrong. We can be orchestrated by other systems like Airflow and Dagster. These sync errors are big showstopper. Something went wrong, we should try again type errors. But data errors are really specific to how data is represented in its final form. And the two big ones we know about today are typecasting errors and overflows, which mean size errors. Maybe the data is too big to fit in a column in Redshift, for example. Data errors should be handled inside the destination, should not be about failing your sync. But we should be able to tell you in your database, hey, this row is weird and had problems in some way. So how do we do that? We rely on the database to do as much of this as we can for us. So for example, we use a method called safecast rather than cast. That's kind of like a try catch for casting. And this also means that we don't need to hold on to customer data to do these transformations. We give the JSON in its raw format to the data warehouse, and then entirely in SQL, we build this secondary table. This is what we call our two-phase loading process. So we actually have a raw table and a final table for every stream that we move over. And this is okay because storage is very cheap in these modern data warehouses. Here's what it looks like. So we start with a raw table, which we put in a new namespace called Airbyte internal. So we, don't pollute your final schemas with this information. But we keep all the data in the rightmost column raw as it came in. So this way, if the schema changes or we got something wrong, the raw data is there and we can always try again. And then finally, we extract that out to that public users table that you're actually expecting at the end of the sync. So this has a bunch of really nice properties that we'll get into in a later slide. But first, we can talk about observability. You'll notice back in the previous slide that we include that meta column early on, so we can start presenting errors and sync information to you from as early into the process as we can, and then it'll get bubbled up to those final tables. So there's four kind of topics when we think about observability that we like to talk about. So extract and load timing. We give you timestamps. We tell you when your data was extracted from the source and when it finally got to the destination. There might be a delay there, and this gives you all the information you need to know about the freshness of your data. We have that today, green check. The two next ones we don't have yet today, but we're planning to build in 2024. So the sync ID to link back to the Airbyte sync that produced the data. So you can then go back to your orchestrators and know, like, oh, this was triggered by Airflow at this time, and here's where the data came from. And also data lineage. We want to give you better information to know from the sources, like, here's the API we pulled from or the source table it came from, and errors like we've been talking about. Giving you all this information in SQL gives you the greatest flexibility to decide what to do when you're doing your work. There's a contrived example down here. When you're counting how many new users there might be in a sync, and you can choose whether to consider the error users or not. This is really powerful because when you're doing aggregations, maybe some column had a problem, but you still want to know how many new users you got today. the count is fine, even if the address column or the age column has an error. But maybe that's not okay for your use case. And again, you can choose how you handle it. That's why we want to give you this data in the database. The last two I'll blow through really quickly. Schema migrations are simple. Because we have this two-phase loading process, we can always rebuild that final table as the schemas change. That means that all schema changes are simple create or replace tables from the raw table into the final table. So as you gain new columns or change types, it's really easy to just do this same operation in an idempotent way. And if anything goes wrong, we can always try again. And finally, see data as soon as possible. Before this change in the V1 world, we used a separate DPT process, which only could run once at the end of the sync, which means while the raw table was filling up, you still got no data in your final table. Now that we do this work in our Java processes, we can run this as often as we want and periodically give you updates to your final tables. Now, this could be expensive and slow, so we have a balancing act to do here. But we think the right cadence looks something like do it immediately for new syncs as the first upload has happened, and then probably every hour as your syncs are running, and then again once at the end of the sync. This is a good balance between letting you see stuff soon so you can see if your tables are right and have what you need, and then periodically giving you these updates throughout long syncs. Some added bonuses. Final table creation is faster. We got better type conversion. And destination V2 is ready today for BigQuery and Snowflake, and coming soon for other destinations that Airbyte manages and has certified. Try it now. Airbyte is open sourced. Enjoy. Thank you so much.